Welcome back to all the weirdos who like videos about coding for buildings. All right, I think this one's going to be a blast because this really is what I had in mind while I was building episode 2 and 3. This is sort of the end game of this exercise. So in episode 4, what we're going to be doing is we're going to convert a color scheme, that awesome tool in Revit that lets you automatically generate color schemes for your plans, for your rooms or your areas. Well, those are amazing. The problem is you can only use them in floor plan views. But we would like to use them in many other places, and especially we would like to use them for rooms in 3D views. So problem number one is rooms are not visible in 3D. We covered that in episode 3. Now, what we want to do is make sure that we can convert those awesome color schemes into something that we can visualize in 3D. Now, this is what we're going to be doing. The scope for this exercise is going to be very similar to those of episode 2 and 3. So this is something this is a format that I will be repeating in some of the episodes of the Orkestra YouTube channel. We're going to be building actual reusable tools with OKPy. Sometimes it's going to be with Dynamo. We're going to be learning about the Revit API, learning some Python in the way, and sharing tips and tricks here and there. Now for this tool, we're going to have a couple of steps to go through. Step number 1 is going to be letting our users pick a room color scheme that they would like to convert into something that they can visualize in 3D. Step 2 is going to be getting all the colors of that color scheme and the parameter values that they are associated with. Then what we're going to be doing, again, is mimicking the behavior of the color scheme in 3D, because there's no real way to do so. So we're going to be creating filters based off the color scheme settings. We're going to be creating filters that use the same parameter values and attach the same colors to them. And then we're going to have to, set those graphic overrides to match the exact visibility settings of the color scheme. All right, without further ado, let's do this. Okay, so for this exercise, I'm going to be picking up exactly where we left at the end of episode 3. So we have an exploded axonometric, well organized here on a sheet. We have some 3D geometry that represent our rooms. And let's now check out the color schemes that we have in this model. So I'm opening the color scheme window and switching to the rooms category. And there we can see that we have a color scheme that's based on the parameter value of the names of the rooms. And this is exactly what we're going to be reproducing with filters in an automated way. If we apply this color scheme, we can see that it automatically uses the parameter values to generate a color scheme. It is really awesome, super powerful. This is one of my favorite features in Revit, and one that I try and introduce as fast as possible to people who I teach Revit to, because this is something that really gets them to understand real quick the power of setting the right data in your model. It allows to automate many things downstream. Okay, so once more, I will be using Revit 2022, and I will also be using Orkestra version 1.6.1, which is the most recent release at the time of this recording. And I will not go through all the description of OKPy. So its concept and the way it operates, all of that is covered in episode 1. I will add a little link to episode 1 that you should see right now on your screens. Please take some time to check it out if you haven't, because it will really help you understand what's going to happen next much better. So I'm going to create a new tool using the OKPy template for Revit. It is going to start a new OKPy project with some useful headers and variables. And as we said earlier, the first step is going to create a way for our users to pick a color scheme from the model. This is the one that we're going to mimic or reproduce with some filters. So I'm starting with a dummy drop-down input. So this is the out-of-the-box drop-down base input. It contains some dummy code with a dummy dictionary. Let's delete all of that. Import CLR. Add the reference to the Revit API. Then I'm going to import the modules that I think I'm going to need for this tool. We don't need to bring everything in here. What we're going to use for sure is the filtered elements collector, because this is, that classic feature that we use all the time to get elements from the current Revit document. And we're going to import it as FEC, which makes it easier to call. And then let's go to the Revit API to look for the class that is representing the color fill scheme, or the opposite actually. So it's called color fill scheme, and note that this is only available ever since Revit 2022. So if you are in Revit 2022 or Revit 2023, you're fine. If you're in Revit 2021, this tool will, well, just not work. I will do an episode about managing compatibility across different versions of Revit, how you can address the changes that happen in the Revit API in between versions. I think it's an important topic. It's something that I do a lot to keep my tools cross-compatible. And yeah, I think there's some value in there. So you can expect to see an episode around that topic. Okay, so we're going to need the color scheme class. So I'm going to import it, color fill scheme. And then I'm going to do a classic color fill schemes equals filtered, or FEC, since we have it imported that way. FEC is faster to type. We have this current doc variable that's built in OKPy. It's very useful. Of class color fill scheme. So this gets us all the color fill schemes in the current project. But as I mentioned quickly during the intro, we have color fill schemes for other things than rooms. And we want to make this very straightforward for our users. We don't want to give them and pollute them with more choices than they actually need. So I want to filter these color fill schemes based on the category that they apply to. So let's see what the Revit API has for us. If I check out the properties of the color fill scheme class, I can see that I have information about the category that it applies to. So we have category ID. Now we can use that attribute as a filter. So room color fill scheme is our new variable where we're going to store this. Little Python list comprehension to iterate through our color fill schemes list. So CS for CS, and color fill schemes if color fill scheme or CS dot category ID equal. This is a neat way to get a category's ID. It's element ID and then built-in category, and call the built-in category that you want to get the ID for. So built-in category OST.rooms, OST_rooms is what it's called. We need to import the built-in category class, or enum actually, if we want it to be recognized by our little snippet here. Now that we have this list of filtered color fill schemes, so they're filtered to only return or only contain the color fill schemes that are going to apply to rooms, we need to create the output dictionary that's going to be understood by our OKPy input. Because remember, that's how we can populate our dropdown. So we need to create a dict, let's call it dict as dictionary, initiate it with little curly brackets, open and close, and then we iterate through the room color fill schemes. So for RCS and room color fill schemes, dict, then for the key, we're going to use the names as the key. That's going to be easy to understand by the users. And then we associate the room color fill scheme itself as a value, RCS. And then we assign that dictionary to the output, so we're good. We rename our output because this is something that's, again, going to make much more sense to our users. Room color fill schemes, all right. They can pick from this list now. And let's give it a little description. A drop down for room color fill scheme single selection, because we could have list views for multiple selections. All right, let's apply it. Not happy, what's up? Cannot import. Okay, there's a typo. Filtered elements, only one L. Still not. Element ID is not defined. That's right, I did not import it. I used it without importing it, so I need to add it to my list of imports. All right, how about that? We have our dropdown. It's called right, that contains the right information. This is looking great. I'm actually going to go ahead and publish this input because this is something that could be used or usable for the community, right? And I could see myself using it again. Now, just a piece of information is, in order to publish custom inputs in OKPy, all you need to have is an OKPy community account. Now, those are free. So, by the way, everything I've been showing so far in the Orkestra YouTube channel, all of it is free. There is absolutely no subscription to have. There's only this part here where you need to have an account. And this is just so we have a form of like social proof, you know, for the tools. You don't want your tools to be just generically uploaded. It's nice to know who's behind it. It's nice to know who you can ask questions to about it. So this is something that's really great. And I think it could benefit the community. And this is also something that you can, an account that you can use to upvote and downvote content that you can find on the OKPy input browser. All right, now I already have an account, so I'm just simply going to log into mine. All right, logging in. Sweet. Now this input is available for everyone. So you can simply go ahead and open the File Preferences window of OKPy. You get to browse the online custom inputs. And if you look for room color fill schemes, you'll find it. It's been uploaded by me a couple of seconds ago. You can download it, upvote, downvote. There's even a little description here that tells you more about what it does. All right, so that was just a little parenthesis that I'm going to close now. Let's move on with our tool. So one thing I did not necessarily mention during the intro, but this is also something that we're going to let our users pick, and that's a view template to apply the filters to. Because this is the most efficient way to centralize and manage those filters and settings, graphic overrides, etc., and to apply them to several views at once. So this is what we're going to create now. We're going to start from a views out of the box input that contains all the views in the model, floor plans, ceiling plans, 3D. It really contains everything. We're going to use that as a basis because I'm being a little lazy. I don't want to recode everything. I just want to modify the code inside that out of the box views input in order to make it return the view templates. So let's rename it view templates. Let's change the description, all view templates in a model. All right. And we're actually just going to change something that we had previously, which is a filter that does specifically the opposite of what we need here. So it was a way for us to filter the templates out of the list, because remember, views and view templates are the same thing for the Revit API. They just have that isTemplate attribute that differentiates them. So here, instead of filtering based off isTemplate equal false, we're going to, well, change false to true, and that will be it. Okay, so now we have our list of view templates. The input is named correctly. Now this is really looking great. It's starting to shape up. Our users can now pick a color fill scheme. They can pick a view template. All right, let's publish it. It is now available for everyone. Okay, so one thing that we did for our previous tools, and I'm going to do it here as well, is I'm going to write down a couple of comments that are going to help us follow the steps. First step is selecting reference color fill scheme. So we're simply here going to store the selected value in a variable that we're going to call room color scheme. It equals, we're going to use the built-in inputs dictionary. Again, check out episode 1. This will make much more sense. Just renaming the key for the input and querying it by its name in the inputs dictionary. All right, that was fast. Step 2 is selecting template to add filters to. Going to do the exact same thing. Store the selected template in a variable called view template. Going to rename it for better readability of the code. Inputs, fetch the input value by its name, view template. All right, we're good now with the inputs. So now we are going to be iterating through the entries in the color scheme. And after that, we are going to create the filter for each entry. And then we will need to apply the graphics overrides to each filter in order to mimic the color fill scheme behavior. Oh, before that, we will need to add filters to the view template, so the one that's being selected. So we create the filter for each entry, we add the filters to the view template, and then we apply the graphics override, because the graphics overrides are applied to a view. Okay, so we're going to iterate through entries in our color scheme, the one that's selected. First, we'll need to get the list of entries. Now, how do we do that? Let's check out the Revit API in apidocs.co. Amazing website. Let's go back to the color fill scheme class. Let's check out its members. Where are the entries? Get entries. How convenient. So this is a method that doesn't take any argument and returns a color fill scheme entry list. So that's another type of object. We'll probably need to check out their attributes. Okay, so this is the selected room color scheme. We're using the getEntries method. So for entry in entries, that's our iterator. So for each entry in our color fill scheme, we're going to really be interested in two things. The first one is the parameter value that the entry is associated with, right? That's also the information we're going to apply our filters to. So getting the parameter value for the entry. So for that, let's store it in a param value and call the attribute. Let's check out the Revit API. So color scheme entry is a class. It has attributes. Get string value. Now, again, this tool here is focusing on a color scheme that has string values. Those could be integer values, they could be different type of values, and we could make our tool adapt to those different values. Now, I want to keep this video a little short. This is mostly about, getting an actual tool out there. And if anyone feels the need to improve it, and if you have any questions about that, please reach out through the forum. We can discuss that and look into it together. And then the second element that we're going to be interested in is the color that's associated with the entry. Okay, let's get back to our param value. Entry.getStringValue, it doesn't expect any argument, so we're good with that. And then getting the associated value color. So let's call it entry color. It equals entry.color. Pretty straightforward. All right. As we iterate through these entries, we need to create a filter for each one of the entries. So we're going to be creating the filters, or create filter for this entry. And well, actually, now that I think of it, there's going to be a need for another input. Now let me explain before I move forward with this. We're going to be creating filters, right? And those filters, they need to be based on a value of a parameter. So what we need to do here in order to make our tool as flexible as possible is let the users pick the parameter that is going to be used for the filters and that we're going to be applying colors to based off their parameter value. Now let's build a new input for that. This input is going to be absolutely the same as what we did in episode 2. So I'm just going to fast forward through it. All right, nice. Now we have this input that we can use to pick the parameter that we're going to filter on. It is based off the generic model class because this is what we use for the generation of our 3D room geometry. Little reminder, I wanted to show you that we have this 3D geometry for the rooms, and the names have been injected into the comments parameter. All right, let's get back to our filter creation. Now, we're going to take a little journey in the Revit API, and just so it makes more sense, and so you don't get lost if you're not familiar yet with all of this browsing of the classes and all the links between the classes, I'm going to try something new and subtitle this part with some sort of visual scripting. I hope this is going to make things clear. So let's get to it. What we're going to be creating here, and this is what corresponds to a Revit filter, is called a parameter filter element. That's the class, right? So this class has a creator, so that's pretty cool, right? And here it is. This is a little nodal representation of this constructor. Hopefully this will help you make a better connection between visual coding and these methods that are found in the Revit API. So this parameter filter element create method expects 4 inputs. It has 4 arguments. The first one is the document. Now this one is really no biggie. We have it, right? It's the current document. We have it stored in a variable. The second thing is the name for the parameter filtered element. And this is also something that is really no problem because we can create it. So again, we can check that one on our list. Third thing is the categories that we would like to filter on. Again, not something that's going to be a problem because we know which categories we want to filter on, and we know that we can build a list with element IDs of the categories that we would like to filter on. So all the way to this fourth input, everything is already there or very easy to build. The last thing that we're going to need is an element filter. Now this we don't have, right? And this is something that we're going to need to create. So this element filter is our missing input for this node to work well. Now let's take a look at this element filter class. Let's see if it has any constructors. We can check out its members. And well, sadly, if you look into this, you'll realize that there is no public constructor. So no way to build an element filter just like that. Now I'm going to save you some more internet research and tell you that there's a couple of classes that inherit from the element filter. So if we use one of those classes, they will work, right? Because they're children of the element filter. Even if they're a different class, they will be sort of considered like the same thing. And I can tell you that if you want to filter something based off the value of a parameter, which is exactly what we're trying to do. We want to use the comments parameter of our Room 3D geometry. So those will be element slow filters. So that's the class we're going to need to look at. If we check out the members of the element slow filter class, you will see that there is no constructors still, no public constructors. So I'm just fast forwarding through a couple of researches that you may or may not have to do, depending on how familiar you are with all of this. But yeah, right here, if we look at the elements that or the classes that inherit, again, from this element slow filter, we will find an element parameter filter class. Now, this is the one we're going to need. If we check out its members, we'll see that it has some constructors. So that's pretty cool. We can create instances of this. So we don't have any filter rule yet. So this is, again, an object that we're going to have to build. And in order to do so, we need to see in the API how we can make that happen. If we check out the members of the filter rule class, we will see that there is no public constructor once more. So again, I'm trying to save you as many internet researchers as possible here. What we're going to be using instead of a public constructor for the filter rule is something that is called parameter filter rule factory. Okay, so this is pretty self-explanatory, right? Parameter filter rule factory. This is going to help us build filter rules, which is what we need. And here's one constructor. It's called create equals rule. Why do I focus on this one? Well, that's because, in Revit, when you create a parameter, you have a couple of conditions: equals, greater than, smaller than, starts with, etc., etc. And what I want to use here for my filters is an equals condition. I want to create filters that are going to apply if the selected parameter value is of a given value, right? So this is why this is what I'm focusing on. Another thing I want to tell you about this is this method here has changed ever since Revit 2022. So it is like this in Revit 2023. I think in 2022, it expects a third input, a third argument, which is it's a Boolean that lets you tell it whether you want it to be case sensitive or not. Now this third argument is gone in Revit 2023. So yeah, just know that if you're trying to reproduce this in 2022. All right, now the inputs for this create equals rule constructor are an element ID and a string, okay? What's the element ID? It's the parameter that we want to filter on, and then the string is the value of the parameter. Now we can check both those items of our list because we have access to both of them. The parameter element ID is actually the parameter that's been selected by our user in the user interface we built earlier. And then the value that we want to check against, or that we want to apply filters on, well, those are actually the parameter values of the color fill scheme entry. And this is also something that we got earlier. So we have basically figured out how to get that parameter filter element created here with this sequence of nodes. With the parameter filter rule factory, we need to create the equals rule. So that's the filter rule. Then that filter rule is going to let us build an element parameter filter, which is going to let us build the parameter filter element. Okay, so I hope this little subtitling thing worked. I think I'm going to be using this some more in the future, especially when there's, well, a lot of things to look in the Revit API that keep us browsing from one class to another. Right, let's get back to our tool and go to the filter creation part. So we need the rule first. That's what we just saw. And in order to build our filter rule, that's what we call our variable, we can call the parameter filter rule factory. So the method is create equals rule. Our parameter is the one that we've selected here. I made a little change in order for it to return, compared to episode 3. I made a change in order for it to return the parameter itself and not its name. Because if we have the parameter itself, then we can simply, well, I need to store it in a variable first because I haven't done it yet. So let's, getting the parameter to filter on, parameter to filter, and going to get it in the inputs dictionary by its key. Now I have the parameter that's selected stored in there, and I can simply fetch its ID like any Revit element. So that's pretty convenient. And then the value is param value. That's the one that we got earlier. That's the entry, the entry's value from the color fill scheme. Now we need to create the filter element. The element filter. So let's store it in an element filter variable. Now we saw that we needed an element parameter filter method in order to create that. That's our constructor. And this only requests our filter rule, the one we built before. Now we have the second step of our little sequence. We need to create the parameter filter element. Filter element. All right. We have all the input it takes to build that. So parameter filter element equals parameter filter element create. That's the method. So current document is stored in the doc variable. That's easy. The second thing is the name that we want to give this filter. I'm just going to give it a prefix. If you've seen the previous video, you know that I like to build tools that are able to update and clean after themselves if they're being run and then run again. You don't want them to generate filters on top of filters. So I use easy to identify prefixes in order to, well, simply delete them in the future. And this is something that we'll do towards the end of this video. So I'm simply going to name those filters axo, because I'm using them in an axonometric view. And then I'm going to add the parameter value. And this will make the filters easy to identify because we'll know which parameter value they are addressing. The step after that is getting the list of all the categories that we would like to filter on. So I'm using the cats to filter variable that we have defined earlier. And I can then use my elements filter. And there we have it. Our parameter filter element is created. Now we need to apply the filter to the view template and give it the right overrides. Now, if you want to attribute overrides to a filter, there is a class that you can build. It's called override graphic settings. It has a very straightforward constructor, unlike the things that we've been dealing with lately. And then it has, all of those methods to set the foreground, the background, the color, the pattern, all of that good stuff that any user of Revit is actually familiar with, because this is what you get in the visibility graphics settings menu and also the filters settings. So this is the same stuff, just through code. Now we're going to build our instance of overrides using the constructor. So that's override graphics settings. Okay, it's not expecting anything. And then we need to set all of our overrides. Okay, so we want to set the foreground, the cut foreground pattern color, and we're going to give it the entry color. And then we want to set the foreground pattern. Now the method for that is called, and I just copy pasted to avoid some typos. It's called set cut foreground pattern ID. And then it's expecting, the ID of the pattern. And that's also something that we can actually query from the color scheme entry. Earlier, we queried the associated parameter value. We queried the color. We did not get the element ID of the pattern. So we're simply going to do it right here. In the API, it says so. We have access to something called fill pattern ID on that color scheme entry. Just going to type it right away in here and add the other overrides. So we're setting the cut foreground color and pattern, then set surface foreground pattern ID. Using the same pattern, obviously. Overrides set surface foreground color and use the entry color once more. Now we're iterating, so we're doing this for each entry. I think we're done with the settings. What we need to do here is apply those overrides. And this is something that we can do directly on a view or a view template. So the view template that's been stored in the variable here is going to be used. Set filter overrides, that's the method. And we simply pass a filter ID and then the overrides. So that's how we apply the filter to the view or a view template, and we associate all the overrides that we want. Sweet. Okay, we can run this, but just before we do so, since we're going to be modifying the Revit model, we need to start a transaction. This is something that you should be familiar with by now if you've watched the previous videos. So transaction on the current document, transaction start, let's name it OKPy, filters from color scheme. All right, and then we need to commit that transaction. Transaction.commit. Nice. Let's see. Run. Okay. What's going on? Make generic type on type. All right. Yeah, well, this is because the list is not the .NET list. It was a Python list. That was just a typo. Another mistake. Expected int got element ID. Right. I think we just need to put this in between brackets to make it a list. Did I make another typo here? Right, it's foreground pattern color, not just color. And here we go. Now this looks amazing. These are exactly our color scheme colors applied to our 3D views through their template. That's why they have all been changed at once. And if we go check out the filters that are applied to that template, here we go. They're all called AXO and parameter value, and they have the right settings. Now this is exactly what I was going for. They are applied to the generic models category, and there's an equals condition on the values of the parameters. Sweet. Now we're almost done. This is exactly what we were going for, right? But there's one thing that's important, and that's the ability to get the tools to update when they are launched over and over again. For example, this cafeteria here is in green, right? So that's what the color scheme has as a setting for the cafeteria name, for rooms named cafeteria at least, right? Now let's say that someone makes a change to that color. Now that's something that happens, right? Color schemes get modified to get something that is more relevant or more satisfying visually, but our filters have not updated automatically. And this was to be expected because this is not something that updates dynamically. It's been generated at the moment we run the script. Now, if we run the script again without any change to it, we will get a lot of error messages, I think, because it will try to create filters using names that are already used, and Revit does not like that. So this is likely to be a mess, right? So one thing we're going to do, and again, if you are someone who's watched episode 2 and 3, you know what's coming. It's going to be a cleanup transaction, something that we're going to add at the top of our code so it gets run before anything else happens. So cleaning up filters, clean up transaction. It's a transaction on the current document. We're going to start it, name it, OKPy, cleaning up color scheme filters, so we know what's happening. Okay. Now what we need to do is get all the filters that we have created with the previous run. What's going to help us doing that is that prefix that I added. You remember the AXO underscore one? So we're going to use the filtered elements collector, the current document of class, and then the class is the actual parameter filter elements that we've been creating. Okay. To delete is going to be using a little Python list comprehension. The filter for filter in all filters, if filter.name starts with, that's the condition. And we use our AXO underscore prefix. Now this should help us identify them amongst all the others. Okay, now we iterate through this list for td in to delete, and we use the doc.delete method that wants the element IDs, so td.id, and finally we can close commit that cleanup transaction. Okay, so this is a tool that is now able to update. If I run it, no function or method attribute name. What is that? Oh, okay. Filter is, I think, a built-in method in Python. So I'm going to name my iterator something else. Let's focus on the cafeteria there, on the first floor or ground floor. And yeah, it's red, just like we made it in the color scheme. Awesome. So we have a tool that's able to clean after itself, able to update, throughout the different modifications that a project can go through. Um, let's just save it. Let's give it a little description here. File, save. And now we have a tool that we can add to our ribbon. Nice. And obviously, just like the previous ones, clicking this button is going to run the tool. So we're going to stop here for today. I hope you found this interesting. I hope this is something that you'll be using in your projects. If anything comes up while you're trying to rebuild it or use it, because I'm going to put it in the description of this video as usual, feel free to reach out. The forum is always there. You guys take care and see you in the next video, which is going to be about building a nice ribbon for Dynamo tools and OKPy tools.